Chapter 8, Lesson 2 of Geometry, and I want to wrap this lesson up by looking at some examples of the types of problems that I expect you to be able to do. Some where we have the triangles related, where you actually have to use some of each of the special triangles, both the 30, 60, 90 and the 45, 45, 90, and then how we can sometimes use 30, 60, 90s or 45, 45, 90s to help us determine lengths of different polygons. So let's do a couple of examples here where I have a triangle here. Actually, I have three triangles. I have the large triangle, and then this dotted line here divides it into two other triangles. So you'll notice that the triangle on the left here is a 30, 60, 90, and then the triangle on the right is a 45, 45, 90. So this is going to be 30 here on the left, and this is going to be 45 on the right. So we are going to have to incorporate what we know about both triangles. Now, if I try to start with 45, 45, 90, I know that the legs are the same length, and then the hypotenuse is square root of 2 times that. The problem here is I don't know the length of this leg, so I can't figure out the other leg, and this leg is also missing, so I cannot determine anything in the 45, 45, 90 to begin with, so I'm going to have to start on the other side with the 30, 60, 90. And again, with the 30, 60, 90, we want to go through our steps. We want to identify the different sides, then decide on which equation to use and work our way from there. So if I'm looking at just on the left here, my 90-degree angle here, so this 4 radical 3 is my hypotenuse. As I look across from the 30, this letter C here is my shorter, and then the letter A here is going to be my longer. Now, I'm given the value of the hypotenuse, so based upon that information, I'm going to start with the equation that says the hypotenuse is 2 times the shorter leg in a 30, 60, 90, and then substitute my value. So the hypotenuse is given to me as 4 square root of 3 is equal to 2 times the shorter, and the shorter in this case is the letter C. So solving for C, I'm going to divide by 2 because that reduces to 1. I'm going to divide this by 2 because the 4 and the 2 are not part of a radical. I can reduce those, so that both divisible by 2. So the letter C is equal to 2 times the square root of 3. So this length here is 2 times the square root of 3. Now that I know the length of the shorter, I can figure out the longer by remembering that the longer is the shorter leg times the square root of 3. The longer leg in this case is the letter A, so I'm going to use that. A is the shorter, which I calculated as 2 times the square root of 3, times then the square root of 3. So the square root of 3 times another square root of 3 is just the number 3, and then that times the 2 gives me a value of 6. So let me do this. So I have the value of A is 6. Now A, if we look on the right side, this 45, 45, 90, A is also a leg in the 45, 45, 90. And in a 45, 45, 90, both the legs are the same. So that makes D, let me see, I'm going to back up just a little bit. Bear with me here. Don't forget. A is equal to 6. Well, A and D are the same, so also D is also equal to 6, or D is equal to A, which is also equal to 6. So I can write that as 1 like that. And now I know that the hypotenuse in a 45, 45, 90, the hypotenuse is equal to the leg times the square root of 2. So now that I know that, I can substitute in these values. The hypotenuse in this case is the letter B. The leg, using A or D, they're both the same, would be 6 times the square root of 2. So B in this case would be 6 square root of 2. So in this case, we had to use both triangles, and again, you have to figure out where you can start with based upon the information you've been given, but you're applying the same principle that you learned with the other parts of the lesson. Okay, in this next problem, we have again a large triangle, and this is a 60, this is a 90, and so I have this triangle on the left. which is a 30, 60, 90, so this angle is going to be 60. And then here this is 60, so this smaller angle is going to be 30. So I only have the 30, 60, 90 to deal with in this particular problem, but the sides are different in each one. Again, we want to identify the sides. So in the triangle on the left, the A here is going to be my hypotenuse. As I look across from the 30, this is the shorter in my triangle that's on the left. And as across from the 60, this is my longer in the triangle that's on the left. Now, in the triangle that's on the right, this value of B, it's the same side. On this triangle, it ends up being the longer because it's opposite the 60. And then 30, D is the shorter because it's opposite the 30. And so the one value that they give me, this value 10, is the hypotenuse in this triangle that's on the right. Okay, and so let me kind of draw this here if I can do this. I don't know if this helps at all, but this is the triangle that's on the right. Okay, so I'm going to start over here on the right because that's the information that I'm given. I'm given the hypotenuse, so I'm going to start with the equation that has the hypotenuse. And the hypotenuse, you remember, is the shorter leg times 2, or 2 times the shorter leg. So the hypotenuse here is 10. And that's equal to the shorter leg, which in this case is D, times 2. So dividing by 2, that's going to give me D is a value of 5. That really doesn't look like much of a 5. It looks more like a B with a hat. Alright, so D is the value of 5. Now that I know that that is D and it's the shorter, I can now use the equation that my longer leg is equal to the shorter leg times the square root of 3. So in the triangle on the right, the shorter leg is D, which I calculated as 5, times the square root of 3 is going to be equal to B. So B is equal to 5 square root of 3. So that solves the triangle on the right. Now in the triangle on the left, this 5 square root of 3 is no longer my longer side because now I'm in this triangle on the left. Kind of draw this a little bit, and in this triangle, B is my shorter side. So given the shorter side, I want to calculate the hypotenuse. So again, going back to our equation, the hypotenuse is equal to the shorter side times 2. So in this case, the hypotenuse is A. The shorter side is my B, which I calculated at 5 times the square root of 3. That times 2. Again, a number that's outside can be multiplied with a number that's outside a radical. So the 2 times 5 is 10. So A would be 10 square root of 3. And then in this triangle on the left, the longer side is this value of C. So I'm going to use the equation that the longer side, you write too fast here, it looks like a Z. The longer side is equal to the shorter, remember, times the square root of 3. The longer side is the variable C in this expression. The shorter side, again, is B, which we calculated at 5 square root of 3. And we're going to multiply that by the square root of 3. So the radical 3 times the radical 3 is the number 3, and that times 5 is 15. So C would be equal to 15. Again, same process, again, looking at 30, 60, 90s, and then 45, 45, 90s. Sometimes you have to use both. Sometimes you'll only use one. So what do we do in a situation like this, where we're given this trapezoidal looking figure and we're asked to determine these lengths and there aren't any triangles there? Well, again, one of the things we want to recognize about math problems is usually when they put an angle measure in here, there's a reason they do that, and that is because they want me to use it. Now, there isn't a triangle here, but I can, with a little ingenuity or just seeing, I can make a triangle. If I just draw a line down here like this, right, then I have created a triangle where this angle is 45, so this one's going to be 45. So I've created a 45, 45, 90 triangle. And now that I've done that, I can figure out the different sides. Now be careful here. A was this entire length here. Okay, so when I cut this off, this length here, okay, is going to be not A, it's going to be something else. So we have to be careful about that. By creating this right triangle, I've also created a rectangle on this side. And you remember from rectangles, opposite sides are the same length. So this side is 6. The opposite side of the rectangle, which is this dotted line I drew, then is going to be a 6. Okay? And then from here to here is 8. So from here to here is 8. Now 8 is not A because A goes the entire length. But from here to here, I know that that is 8 because of the rectangle that's been created. Alright? So in order to find out A, I need to take 8. I'm going to need to add to it whatever this is here. So let's just call this X for right now, and let's figure out what that is. Alright? So X is a side of a 45, 45, 90. We know in a 45, 45, 90 that the lengths are the same. So if this side of the triangle is 6, then this side must also be 6. So the length of A then is going to be this side of the rectangle that was created, which is 8, plus the side of the triangle that I created is 16. So A is going to be equal to 14. And now that I know these are the legs and the legs is 6, I remember that the hypotenuse of a 45, 45, 90 is equal to a leg times the square root of 2. So if the leg is 6 times the square root of 2, that's going to give me my hypotenuse, which in this case is equal to the letter B. So a little bit of kind of puzzle solving there, and recognizing that if there's not a triangle there, I can draw one in there and use the information that they've given me and then apply one of the two triangles to that figure.